We are looking at this board which was manufactured, and we are going to make a little test campaign. And today we are checking the various test points for this board. So let's get back to the lab and check some of the behavior on this board and how the instruments on the lab actually behave themselves. Morning, this is Jean-François from Chrysalide Engineering. We are still working on the lab, and this time on this circuit board. If one remember, this is a voltage reference. We have input channels for BNC and 4mm jack, power supply, FPC connections for the I2C readings through the microchip U4 over here, which has an internal reference very well calibrated, and we have also a 10 volt class A 0.1% voltage reference over here. Two sample boards have been manufactured and are tested working well. And something interesting I have observed is about this HP oscilloscope. It seems to be very accurate, but only for a couple of minutes. And when it's warming up, then there is an oscillation on the signal, and it became quite out of range, out of tolerance. I also noticed this Electronique TDS 1002. Though it's a good oscilloscope, I can't really have an accurate reading on the analog reference. Right now I'm reading 10.1 volts, minimum 10.1, maximum 10.1, average 10.1. And I should get 10.0 actually, simply because the LM4040 class A from Texas is a 0.1%, 10 millivolts tolerance, so 10 volts, maximum 10.01, minimum 9.99 volts. I get a good reading on the multimeter. This meter from Ideal seems to be quite accurate, it's reading 9.99. TP2 power supply, we have 12.5 volts. It's not very well regulated. Here is how the power supply looks. The power supply has a 250 to 300 millivolts peak oscillation at 4 kilohertz, so it's not well regulated, but that's our power supply. We have 3.3 volts on TP6 used for the microchip ADC. Minus 5 volts made by the board from the minus 12 volt we see over here. So the power supply and minus 12 volt are not well regulated. They need to be regulated from outside. But the minus 5 volt is regulated. And that's because we want a shift on the ampli up. We want a negative power supply to be able to read something slightly negative on the inputs as well. The multimeter reading 9.99, 10.00, we are good. Tektronix reading, I can only get 10.1 average. I don't know if it's possible to get more digits, but I couldn't figure out, so 10.1. If we have some calibration method, we can use them through this TP3 with the jumper JP1 open. We want the TP3 to output our voltage ref. Here we are looking at the HP 54510A digitizing oscilloscope. It's a scope from the 90s, I guess. It is we are reading right now 10.01. I'm recording this value, 10.0180. This instrument is right now reading very accurately. We know that this is intolerance because we know this diode maximum voltage will be 10.01 volts. But the interesting point is after a couple minutes we start to see an oscillation and the reading drops quite a lot. It is already dropping right now. So this meter is working well only when it is cold. When it is warming up, it will become far out of tolerance. We are about 1 minute after boot, and we see that we have 9.98 reading. We are about 2 minutes after boot, reading 9.96. The reading hasn't changed on the meter, we are still 10.00 volts. The reading on the oscilloscope is now average 9.93, so we are about 7% low. 9.93 volts, and we see this oscillation over here. And I'll get this oscilloscope off because something is happening in the capacitors, I guess, and I will talk about this a moment later. This board is giving good results, and we can already see the issues with two of my oscilloscopes, which are quite well calibrated, but this one is calibrated only for a couple minutes, as we can see, so it will need revamp on the capacitors, and this one needs a bit of calibration nowadays. So this board is doing the work, is fine, I'm satisfied. And I guess the capacitor, when the oscilloscope is getting high in temperature, start to have some leakage. Most probably we have like electrolyte or capacitors on some components are doing a bad job when they are getting hot, and that's probably the age of this oscilloscope. So, but the behavior is so that it is working fine with very good accuracy for a very short period of time. Here is how the board works. We can plug the jumper JP1 between 2 and 3 for the BNC input, or between 1 and 2 for the terminal input, the green and blue terminals. And I have now plugged the jumper for BNC, and I am using this probe, this external probe. The probe is a standard 1 or 10 meg oscilloscope probe. It's working a little bit better on 1 meg. We have a non-preop stage at the input, so we have a high impedance, and therefore we don't have any divider, so it doesn't matter what is the impedance and what is the tolerance on this impedance on the probe, because we are measuring without any current, so we have a high impedance input. And let's check, for example, the second board is now just power supply, and I'm checking the 10 volts ref on the second board. And we can see that the output is reading also 10.1 volts. And so the advantage of this setup is that now this oscilloscope probe is presenting a high impedance to the circuits that we are measuring. And we are measuring this 10.1 volts. You can subscribe if you're interested, either on the channel and on the download section as well, where news will be posted. Eventually see the store with some of the design available, and one of these boards is also available on Electro, so you can get it from there with a reasonable price for 95. Thanks for your support. Subscribe to the channel if you want to follow our works or share some information, thoughts and comments.